Space, vast and awe-inspiring, stretching in all directions. Our universe is an immense expanse that we can observe and explore. With the most powerful telescopes, scientists map not only stars but billions of galaxies and their clusters, peering farther and farther into the past, all the way to the Big Bang. But can they find out if there's something beyond our universe? Is there anything out there where even the mightiest instruments cannot venture, let alone cast a glance? Hello, dear friends. In today's video, we would like to explore the question of whether there is anything beyond the boundaries of our universe. But before we dive into that, we would like to ask you to subscribe to our channel and hit the notification bell to be the first to see our new intriguing videos about the mysteries of the cosmos and our planet. Before we discuss what lies beyond the universe's borders, let's first understand what these boundaries are. To do that, let's rewind approximately 13.8 billion years ago. At that time, our universe existed as an extremely dense and hot object called the singularity. Then came the explosion, and the universe began to expand and cool down. This event is now known as the Big Bang. Check out our video dedicated to this topic by clicking the link in the top right corner. Over time, particles and energy began to combine, forming atoms and later molecules, from which the first stars and galaxies emerged. Observations show that the universe is still expanding, with galaxies spaced far apart, and the distance between them continues to increase at an accelerating rate. So we have singularity, Big Bang, and expansion of the universe. Today, we see the universe as it exists approximately 13.8 billion years after the Big Bang. Now, let's talk about the boundaries. However, it's worth noting that the concept of universe boundaries might not be entirely accurate, as space and time may not be as we traditionally understand them. The size of the universe depends on the definition of distance due to the non-constant nature of its spacetime. Nailing down the actual boundaries of cosmic space has proven elusive for humans. However, scientists have tentatively identified where the metagalaxy ends, the observable part of the universe visible with powerful telescopes and other equipment. The metagalaxy includes star clusters, star systems, nebulae, everything visible to the human eye. This space, where we can discern scattered radiation, is considered the boundaries of the observable universe by specialists. According to astrophysicists' calculations, the radius of the so-called Hubble sphere formed as a result of the Big Bang is about 46 billion light-years. However, there's also the concept of the Hubble volume, representing only the part of the cosmos visible to our technology. It's believed that the Hubble volume is approximately 13.8 billion light-years. Modern cosmology proposes several scenarios regarding the universe's limits. Closed universe. In this model, the universe resembles a surface, similar to a sphere. Therefore, moving in any direction will eventually bring you back to the starting point. In this case, the universe may be finite but without definite boundary. Open universe. In this model, the universe expands indefinitely and space is boundless. There are no specific boundaries and the universe is truly infinite. Flat universe. In this model, the universe has a flat geometry and its dimensions may be limited. In this case, the universe can be envisioned as one side of a parallelepiped. It's flat but has definite boundaries. In general today, the boundary of the observed universe is set at around 13.8 billion light-years. However, this doesn't mean the universe ends there. It simply means we currently cannot see beyond that point. This brings us to the concept of the cosmological horizon, a sphere in the universe where points have infinite redshift. The time it takes for photons from this sphere to reach us equals the age of the universe. Due to this, we cannot see objects beyond this sphere, even if they exist. Even with the speed of light, the cosmic speed limit, there's a fundamental limit to how far back in time we can look. If we continue to gaze into space, we'll witness events that occurred in an even more distant past. However, this will only get us closer to the edge of the universe. Reaching the farthest part of the universe is impossible, even at the speed of light, as objects far apart continue to rapidly increase their distance from each other. So, we've established the limit of the universe, but the main question remains unanswered. What might be there if that is indeed the boundary? Scientific theories about what could exist beyond the universe are typically based on assumptions, deductions from known physical laws, and mathematical models. Let's explore a few of them. One theory suggests that our universe is just one of many parallel universes that exist alongside ours. This is known as the multiverse theory, where each universe has its own unique features and properties. If you travel long enough, you might eventually find a planet similar to ours, where we had oatmeal for breakfast, or another world where we had eggs and sausages for breakfast, or a world where we didn't have breakfast at all. In essence, there could be a world where multiple paths, or so-called quantum branches, exist, where various versions of universes are possible, containing all the possible actions we can take. There's a paradox in trying to comprehend the vast, potentially limited yet infinite nature of the multiverse, because it surpasses the capabilities of our imagination. These ideas find reflection in string theory, which considers the fundamental building blocks of the universe as tiny vibrating strings. Comment below if you'd like to learn more about this. If we assume that beyond the visible universe it simply continues, then familiar physical laws would still apply there. However, there's the bubble universes theory, suggesting that our universe is inside a massive bubble, constantly expanding. The main idea is that shortly after the Big Bang, the universe experienced exponential expansion. During this moment, various bubbles formed, inside of which individual universes developed with different laws of physics and properties. Because each of these bubble universes has unique initial conditions and characteristics, some may be inhabited while others may not. The concept of bubble universes emerged as an explanation for the anthropic principle, the idea that our universe seems so suitable for human existence that we might be living in one of the many universes suitable for it. However, directly entering another bubble remains problematic since space between bubbles continues to expand. The space between them might be empty or possess its unique properties. The idea of the dark flow was proposed in 2008 by astronomer Alexander Kashlinsky. Studies showed that some galaxies and galaxy clusters move at greater speeds than expected based solely on gravitational interactions. Based on this phenomenon, the hypothesis arose that in distant regions of the universe, beyond our observation, there exists a vast volume of matter that exerts additional influence on the motion of galaxies. However, this hidden mass is not detectable using regular optical or radio telescopes. This concealed mass is termed the dark flow. Some scientists believe it may be linked to irregularities in the early universe remaining after the Big Bang. The structures of these irregularities could be anything, either massive accumulations of matter and energy or wormholes that conduct gravity from somewhere else. Some scientists also speculate that beyond the observable universe, there might be absolute nothingness. This means that space and time, as we understand them, simply do not exist beyond our universe. There are no physical laws or information, just sheer nothingness. What lies beyond the horizon of our understanding remains unknown, like an unfathomable symphony of the universe. However, perhaps it is in this mystery that its infinite charm lies. The distant light of stars reminds us that the past is the key to the present, and our pursuit of discovery and knowledge is the engine of progress. Thank you very much for watching. If you enjoyed this video, don't forget to like it and subscribe to the channel to watch our new videos about the mysteries of the universe. Comment below about what you'd like to learn in the next video. Thank you, and see you next time.